Hey guys, how's it going? It's Mr. Louie. So what I'm going to do today is discuss this activity 2.1.6, solve that trust. So as you guys know, the whole goal of this is to look at this trust and kind of step through the process on how to isolate different kinds of variables and figure out what your unknowns and known values are. So we're going to look here at step one, and step one tells us that we are going to draw the truss in the box to the right and show and label all applied forces. You're going to replace any pins and rollers with the appropriate reaction forces. And the note they tell you here is to make sure to use the correct notation for different forces. So, if I click here and hide that, you'll see here, this is the truss they give us. We have points A, B, C, D, and E, and we're given three forces that are pointing in the downward direction. Force of D is a 1,000-pound force, which is shown right here where my cursor is. Force of B is 250-pound force, and then force of E is 500-pound force. So when we look at that and we want to draw it, what we're going to do is we are going to let me insert a new page actually. Let me do that. Okay. So what we're going to do though is we're going to modify this to be show our reaction forces. So right here, we have to recognize what are these two symbols? What do they represent? This first symbol, it actually represents a pin. And then this second symbol, right, when it has those wheels, is a roller. So when you see a pin and roller, what I want you guys to think about is how many reaction forces does each of these have, okay? So again, the first one's a pin. And when you're thinking about a pin, you want to think about how does a pin work? What forces does it prevent? So can I move this truss up and down? Can I move it left and right? What degrees of freedom is what they call it, am I able to do? So for this particular thing, if you want to pause right here and think about it, you can, or you can continue on and I'll tell you. But for this particular pin here, a pin's going to always have a force in the upward direction, and in this case, we're going to call that the reaction force, R, at joint A in the Y direction. So we're going to call that RAY. All right. And then a pin also has a second force going to the right or going back into that pin. These are assumed directions right now. And when we actually solve for everything, you'll find out if it's a negative number, that means that our arrow was in the wrong direction. But in this case, we're assuming it's going up into the truss. So we have RAY, and then we're going to assume it's going into the truss, going to the right, which is our reaction force at joint A in the X direction. Okay? So after you have RAX and RAY, we are going to look at this side here on the right. We are going to look at our roller. So when you think about a roller, how does that roller, how is that going to actually be affected as far as if we had something on a rolling, like a pin or on a wheel, can that truss move left and right? Will it be able to move in this direction with those wheels? The answer is yes, all right? So with our roller, and I'm going to have to delete this because of how the screen Castify works, but I'm going to hit clear here, and then I'll write these again. So again, on the left side of your pin, you have your reaction force at joint A in the Y direction, and you have your reaction force at joint A in the X direction, okay? And then for this one, we just have a reaction force at joint C in the Y direction. We don't have any force going left or right because that truss can move or it can expand left and right because of that rolling joint. It's allowed to move in that X direction, left and right. All right. So after we determine that, the next thing that we would want to do is we would want to label all our applied forces. We did that. So then, like I said, we could call this F of D because that's the force that's being experienced by joint D here. This right here at B could be called F of B. And then this joint here at E, this force is going to be FE. Later on, we're going to end up solving for various angles because we're going to need this for when we talk about the method of joints in step 5. So I'm just going to call that theta 1, theta 2. Again, theta is just a Greek letter that shows the angle, right? Theta 3, theta 4, and we have an angle here, theta 5, and theta 6. So having all these angles here will help us later on when we are trying to solve for everything. All right. So if you need to, pause the video here because I'm going to move on to step 2. But in order for me to do so, I have to clear my drawings. So I'm going to clear it right now. All right. So the next step, you guys, that we're going to do is we're going to try to figure out, well, step 2 is asking us, let's read it. Check to see if the truss is statically determinate. So what does that mean? Well, it basically means, can we even solve it? Is there enough information given to us to where the number of unknowns that we have, or those reaction forces, are going to be able to be solved? So you may not remember this, but for a truss, all right, a truss has a equation where you can check for static determination. That equation is just 2J equals M plus R. All right? So in this case, guys, J is going to be your number of joints. All right? And then M is going to equal the number of members. And then R is going to be your number of reaction forces. Or number of reactions as well. Just write it out as. All right, so we have 2J equals M plus R. And right now I'm going to actually erase a couple things here. Actually, let's see if we don't erase it. Let's just try to use the mouse. Oh, just stay there. Okay, good. So what we can look at now is our drawing from above, because this will help us determine, is this statically determinate? So if we are looking here at the number of joints, trying to solve this left side of the equation, we'd want to find out how many joints this truss has. So we have a joint at joint A here, a joint here at B, a joint here at C, a joint here at D, and a joint here at E. All right, so if I were to write this below, that means we have 5 joints, right? J is going to equal 5. So the next thing that we're going to do is try to find the number of members. All right, and I'm going to do this in green. So the number of members is going to be the lines between your joints, right? They're going to be those beams that are going to be between the joints. So we count that. We have 1. We have the member from A to B, 2. The member from D to B, 3. The member from D to E, 4. The member from B to E, 5. The member from B to C, 6. And the member from E to C, 7. So this number is going to equal 7. So the last thing we got to do, guys, is figure out how many reaction forces we have. And I deleted these, but you remember there's a reaction here, RAX. There's a reaction going up, RAY, because the pin has 2 reactions. And then there's another upward reaction in the Y direction, RCY. So that means our reactions here are going to be 3. All right? So if we take 2 times 5, that's 10. And we take 7 plus 3, that's also 10. So this equation ends up equaling 10 equals 10. And if that's true, which it is, then that means that we can actually solve for this truss, okay? So again, if you want to take this in, please pause here, think about what I was talking about, and then you can continue on to step 3. Step 3 is going to be a little more labor intensive, but I will talk about that in the next video.